Hello people, this is our second video of a relativity series, and in this video we are going to study about transforms, different transforms like Gaussian and Lagrange. This is very important for the exam perspective. If you are in BSc or you want to study physics for upcoming exams, UG or PG, then this video will help you out. If you haven't watched our previous video of relativity series, I would recommend you to watch that first and then come to this video. So let's continue. What is a transform? So let I have explained you about frame of references in the previous video. So let's see this figure first. Imagine this is the frame 1 and this is the frame 2, and this is the observer in frame 1 and this is the observer number 2 in frame 2. This observer is watching a particular event, and according to this observer, the the position of the particle or the event is something. So how you would know the position of the same particle according to the different frame of reference, which is xyz, because we have taken a general value. So this is what we going to learn in this video. So first is Gaussian transform. Equation relating two sets of coordinates of the event in the two system are called transformer equations. If the two system of inertial, then transformation is called Gaussian transformation. So what is inertial? I have explained in the previous video, but I will give you a sense of it. So if any frame of reference is not having acceleration, imagine two frames. Imagine a person sitting on a platform and train moving with a constant velocity. So neither the person nor the train has the acceleration. This has zero velocity and this has constant velocity, which means acceleration is zero there. So if this is called the inertial frame, so the both frame has to be inertial for this uh, Gaussian transform. Okay, so let's suppose this is a particle, and according to the first frame, this is the position of the particle, which is x dash, y dash, and z dash, or you could say x y z. Let's suppose x y z is the position according to the first frame, and x dash, y dash, z dash according to the second frame. So this is what I have written, that there are two frames S1 and S2, and observer O and O dash. Okay, so you can see this. Let's derive this, the equation. So this is the material. You can copy it. I'm not gonna explain this because this is just supposing thing and all. So from from figure we can say that x dash, which is this, is x minus vt. Let me explain how it came. So, let's suppose this frame is at rest and this frame is moving at the velocity v. So since this is an inertial frame, hence the acceleration is 0. So how much distance will it cover in t seconds? So v is equal to u plus at, and a is 0. So if, sorry, s is equal to, we will not use this formula, we will use s. S is equal to ut. Ut means u is the velocity, ut plus half at square, since a is 0, so we'll not write that. So distance will be ut, and for this case we have u is equal to v, so we use vt. So the frame in this frame in t seconds will cover vt distance, and this frame is at rest. So for this frame it is x, and for this frame it is x plus vt, because it has traveled vt distance. So what we'll do is, to calculate x dash, we will minus x minus, we will do x minus vt, because we know that the difference between first x and second x will be vt. For the previous x it is 0 distance, for this is vt, so the difference is vt. Y coordinate is not changing, because only we are going to consider only x direction. Every other coordinate will be the same. So y dash is same, z dash is same, t time is same for every frame, time does not change. So this is what it is. We can write x to r. So replace x to r dash and r, and we will get the required equation. You can copy it. If you have not understand, you can ask me in the comment section, or you can watch this video again. And what is inverse? So what we have done here is x dash is equal to x minus vt. In inverse, we will uh, we will calculate x rather than x dash. So this will be the equation. If you send x dash to here and x to here there, then this equation will look like this. So this is the inverse transform. And now we have a heading of transformation of velocity. So let particle moves with the velocity u and u dash. So this is nothing but you have learned, you have studied about equations of motion. So this is the equations of motion in different frame. So this is what we have find out in the transform. Let's differentiate it. When you differentiate it, it is that with respect to time, it is written the velocity of the object with respect to the first frame and the second frame, and this is t will become 1, and so this is the required equation of velocity. You can understand it, you can write it, because for the exam perspective it is very important. Some proofs are being asked from this chapter. There are only few proofs which are important, and this is one of them. This is the Gaussian transform of velocity and Gaussian transformation invariant. Invariant means it is not going to change, and it is not invariant. Above result we call say that velocity is not invariant. And so what is it is not invariant means it is changing. Why it is changing? You can see that time is invariant. Time is not changing with respect to the frame, but velocity is going to change. Let's suppose a car is moving at 30 km per hour in this direction, and if you start moving on a bike with the same speed, you will feel that the car would feel you like with the same velocity. You will feel it at the zero speed. So this is what it means, the invariant thing. What is transformation of acceleration, supposing thing and all, and let's double differentiate it and we will get the acceleration. This is what we have got in the previous proof, and if you again differentiate it, it will become the acceleration, because this has no t in it, so it will become 0. And here we can see that the acceleration in both frame 1 and frame 2, it is the same. So acceleration is invariant, it is not going to change. If the acceleration is something in the first frame, it will be the same in the second frame. So since the acceleration is same, we can multiply by m in the both sides, and so f is equal to ma we know, and f dash is equal to f dash we get. So the force is also the same. So if you are feeling the force 10 newtons in the first frame, it will be the same in the second frame. Force is not going to change. The force is also invariant. So this is the second heading, Newtonian relativity, which we will study in the different lectures. So that's all for this video, because I'm going to make shorter videos so that you don't get bored. So if you want another series or videos quite frequently, you can comment down below. Thank you.